And the debate about the safety of humans when dealing with robots gained global attention after the incident report was revealed by Tesla's Giga Texas. The report mentioned that a human operator was pinned against the wall by metal claws, and after seeing this news make headlines, it brought back that old fear that machines might turn against us. In recent years, failures at Tesla factories in the United States and also in industries in Japan have resulted in accidents that shocked the internet. Today, on Amazing Reality, we're going to analyze the real facts behind these episodes, the risks of autonomous routes, and how science and technology are racing to build a truly safe environment for our coexistence with these machines. We will also see a very impactful announcement from Anthropic, saying that its AI can now practically replicate itself by creating other artificial intelligences much more powerful than itself. In addition, we will see robots figuring out how to walk on their own, sensors that allow robots to see through walls, and machines inspired by bees that learn to navigate using less memory than a single photo takes up on your smartphone. Let's understand all of this. Hello, impressed men and women. I'm Carlos Salvis, and you're watching Incredible Reality. A human operator pressed against the wall by steel mechanical arms. Head, back, and arm injuries. The factory floor turned into a horrific scene. For decades, scenes like this belonged only to the realm of science fiction, fueling that fear of machines out of control. But in recent years, real reports from the United States and China show that the dangers of advanced robotics are not just science fiction plots. In this episode of Amazing Reality, we're going to separate sensationalism from facts so we can understand what's really happening when machines fail and why engineering is racing against time to make this coexistence safer for us. This first case here that caught the world's attention happened at the Tesla Gigafactory in Texas. The incident report revealed that in 2021, a software engineer was performing maintenance on two machines that had been turned off. The problem is that a third robot responsible for handling aluminum parts remained active by mistake. Without any awareness of its surroundings, the robot grabbed the human worker from behind and by the arm, leaving a red trail on the floor of the facility. The incident wasn't due to a rogue AI, all right, my friends. It was the result of an operational failure in an environment where the machines have enough strength to move hundreds of kilos. In other words, they can do some serious damage there. And this kind of risk increases as automation spreads. In China, for example, there's a video that went viral showing a humanoid robot moving in an apparently chaotic way. And all of this happened inside a factory with humans nearby. The robot went beyond the limits set for its testing area and started making violent movements close to the workers. The footage, of course, quickly fueled those theories about machines out of control. But the reality, my friend, was much simpler, and precisely because of that, also much more worrying. Investigators pointed to programming errors and also software failures. The robot wasn't furious. It was just doing exactly what the faulty code told it to do. And this reveals a rather uncomfortable truth. The immediate danger of these modern robots isn't that they gain consciousness or even have malice against us humans. It's the combination of physical strength and a total lack of understanding. An industrial robot still can't tell the difference between a metal sheet and a human arm or body. It just performs movements, but with brutal precision. And the problem becomes even more apparent when robots start leaving factories and entering public environments. At a technology festival in China, videos showed a humanoid robot moving in a rather unexpected way, and it did this by moving toward crowds and caused panic on social media with people saying the machine was attacking humans. Some even talked about a machine rebellion. However, later technical analyses pointed to sensor calibration problems and common hardware failures. Even so, these episodes reveal something very important. Just a small unexpected movement is enough to cause psychological discomfort and distrust among people nearby. And something similar happened with the humanoid robot G1 from Unitree, also there in China. And this episode was recent, okay? In that incident, the robot, while performing those fighting moves that were choreographed and not autonomous for now, okay? It kicked a boy who was watching in the audience. Another recent episode also shows a humanoid robot losing control in a restaurant. And now, my friends, with the arrival of increasingly autonomous robots, meaning those that choose what to do without relying on remote control or pre-programmed choreography, the challenge of safety has reached a new level. Engineers are already working on a new generation of collaborative robotics equipped with synthetic skin sensitive to pressure, with three-dimensional computer vision, and systems capable of instantly stopping movement when detecting human presence. In addition, physical locks independent of the software are being incorporated into the machines, ensuring that a digital failure can never override the basic protection mechanisms. So, just to make it clear, okay, my friends, today's accidents are not proof at all that Skynet is secretly emerging, you see. They are the hard lessons that engineering needs to learn in order to build the safe machines of tomorrow. But just so you don't get your hopes up, don't completely rule out Skynet either, okay? At least not for now. Let's see how these AI systems are learning to walk on their own when they're put into robots, including humanoid robots. Now imagine turning on a completely blank machine with no instructions on how to move its arms or legs, just the robot stretched out there on the floor, and watching before your eyes as it figures out on its own how to balance that body and move like we humans do. First come the falls, then the awkward movements, and next, small, still very hesitant steps. And finally, a stable walk, almost natural. What looks like the birth of an animal is actually one of the greatest revolutions in modern robotics. The era when engineers programmed each joint manually is coming to an end. At this point in the episode, we will explore how artificial intelligence has learned to master its own body, and why this represents a historic change for machines. Before, teaching a robot to walk meant calculating thousands of mathematical variables. Every angle, every tilt, and every balance adjustment had to be fully programmed by hand by a human. But everything changed with reinforcement learning. Instead of receiving detailed instructions, the machine now learns through trial and error. It tries out random movements, falls countless times, and receives virtual rewards when it manages to move forward or maintain its balance. Little by little, my friends, artificial intelligence figures out on its own which strategies work best. And to speed up this learning even more, companies like Figure AI and Boston Dynamics have created, we could say, parallel worlds inside supercomputers. Millions of digital copies of these robots live in accelerated simulations, stumbling, slipping, and facing obstacles for thousands of virtual years in just a few real hours. When artificial intelligence is placed in physical hardware in a robot here in our world, and it is finally turned on, the AI already comes into our world with a huge amount of accumulated experience. This method became known as Sim-to-Real Centurion, but researchers at the University of California, Berkeley, and Google Brain decided to take an even bolder path. Instead of training inside computers, they put the robots with artificial intelligence directly into the real world. Walking on carpets, mattresses, and uneven surfaces, these machines learn to walk in just a few hours. The secret lies in proprioception, a kind of internal sense that allows the machines to perceive weight, pressure, and balance. And this basically happens in the same way our brain receives information from our muscles and joints. And the speed of this evolution is impressive. In 2020, for example, Google's Rainbow Dash quadruped took only 3.5 hours to learn how to move on its own. In 2021, the bipedal robot Cassie was already able to walk, squat, and carry loads using only neural networks. The following year, researchers broke another record by teaching a quadruped to walk in the real world in just 20 minutes. But it was now, in 2026, that the machines finally began to leave the laboratories for good. In China, the humanoid Agibot A2 made an autonomous journey of more than 106 kilometers between Suzhou and Shanghai. He walked for about 56 hours. Meanwhile, in the United States, the new Atlas from Boston Dynamics underwent weeks of training using reinforcement learning, and as a result, it started performing extremely complex tasks, from sports-inspired movements to carrying loads over 45 kilograms. And it did this by constantly adjusting its balance. But perhaps the most impressive achievement of this new generation of machines isn't strength or speed, but rather the ability to learn from our real world. For the first time in history, robots are no longer just following programmed movements. They're starting to figure out on their own how they can interact with the physical world around them. And if artificial intelligence has learned to control its own body, the inevitable question is, how long will it take for it to surpass human agility? If it hasn't already, right? Before you answer that question, I want to let you know that human engineers have just announced that now AIs can practically replicate themselves, creating artificial intelligences that are better than themselves. Let's try to understand this. It's interesting. An artificial intelligence capable of writing code, correcting its own mistakes, and taking part in creating systems even more advanced than itself. In other words, other AIs. This idea was in the realm of science fiction for a long time, right? And of course, this fueled stories about machines that evolve beyond human control, like Skynet, which we mentioned at the beginning. But now in 2026, documents released by Unprofit have reignited a debate that, until recently, seemed distant. And at this point, let's analyze how artificial intelligence is starting to take part in its own development, and why safety researchers treat this process so seriously. Behind the scenes at the major Silicon Valley labs, much of the heavy lifting when it comes to code creation is no longer done exclusively by human programmers. The Unprofit Institute report revealed that the industry is entering the so-called synthetic code era, where artificial intelligence systems help write, review, and test the very software that drives the next generation of artificial intelligence models. The numbers are quite impressive, okay? With tools like Cloud Code, about 80% of the code used in Unprofit's internal systems was already being generated by artificial intelligence as of May this year, and this allowed the amount of validated code per day to multiply by about 8 times, compared to the levels observed in 2024. According to Jack Clark, the company's co-founder, the pace of artificial intelligence progress keeps accelerating instead of slowing down, as some people suggest. And this has compressed the time needed for advances in areas like medicine, science, and engineering. This evolution also shows up in autonomy tests, okay? At the beginning of 2024, cutting-edge models could only work on their own for just a few minutes. A year later, Cloud Sonnet 3.7 was already performing complex tasks for about an hour and a half. And now, in 2026, CloudOps 4 has shown the ability to remain performing sophisticated tasks for up to 12 hours without any human intervention. In tests like USW Bank, aimed at correcting errors in real software projects, and Quark Core Bank, which measures the ability to reproduce scientific research, the advances happened at a surprising speed. But the researchers themselves warn that there is still an important difference between operational autonomy and full autonomy. Human beings, at least for now, still define the objectives, evaluate the results, and supervise the most powerful systems. And the greatest fear of the security community? It's not that machines become conscious and can do everything on their own out there, but rather that the speed of technological evolution might surpass the human ability to audit and verify what the artificial intelligences themselves are producing. That's why Anthropic has already started talks with lawmakers and security experts to discuss new forms of oversight and validation. After all, my friends, if an artificial intelligence is no longer just a tool and is becoming an active participant in its own evolution, maybe the most important question is no longer, when will this happen? We know it's already happening, right? But whether we'll be prepared to keep up with how fast all of this is moving, right? In fact, in my book, I talk about some things similar to this. It's a fiction book that talks about what's happening now, this whole revolution we're seeing right now, and what could happen in the future. So, if you like to read and you like fiction, it's interesting. It's available on Amazon, okay? Just click on the link in the description and you'll find it. I'll also leave it in the pinned comment. And taking advantage of this little promo here, I'm going to leave another message for you that's really important. Pay attention, okay? Don't skip it because it's important. And before we start, let me tell you something, okay? It's 100% safe and 100% reliable, and as proof, you don't need to use your credit card, all right? I've been emphasizing here that you can already try out our artificial intelligence, Aria, for 15 days for free, right? But the news now is that our AI, Aria, gives you the power to simply record everything live. In-person meetings, calls, video calls, and even that conversation when you're on the go. Just ask and Aria does the heavy lifting for you. She transcribes everything automatically. She summarizes, highlights the most important decisions, and turns everything into organized actions. And there's more, okay? When you activate AX Fusion, Aria chooses by herself which artificial intelligence is best for each task you're doing. Cloud, ChatGPT, Grok, DeepSec, and many other AIs are all inside Aria, all organized and managed by our AI. And you can trust it, okay? Aria is amazing. There are more than 120 artificial intelligence agents ready to work for you. Don't believe it, my friend? Check the description or the pinned comment and start using your 15 free days right now. Help me out and I'll help you, okay? Let's go. Let's continue now. Seeing an object or someone hidden behind a concrete wall or detecting a person before they even appear around a corner seems like the kind of ability we see in DC or Marvel, doesn't it? But researchers at the University of Pennsylvania have turned this idea into real technology. They developed Holoradar, a system that combines radio waves and artificial intelligence to allow robots and autonomous vehicles to perceive what is beyond their field of vision. And the most impressive thing is that this capability doesn't depend on cameras or lighting. It uses the very structures of the environment as part of the perception system. Today, any system without this new technology basically depends on what is directly visible. A pedestrian hidden by a truck or a forklift appearing from behind a shelf represent very dangerous blind spots. The solution found by the researchers was to turn a characteristic of radio waves, previously considered a limitation, into an extraordinary advantage. Radio waves have much longer wavelengths than light, which means that surfaces that seem rough, like walls, floors, and ceilings, start to behave like real electromagnetic mirrors. The hollow radar sends signals that reflect off these surfaces, bypassing obstacles, reaching hidden objects, and then returning to the sensors. But interpreting this tangle of reflected signals is extremely complex, and that's where artificial intelligence comes in. The team's algorithms filter interference, analyze signal patterns, and reconstruct the three-dimensional image of the hidden environment. For example, this lets the system identify a pedestrian near an intersection before they're visible to the vehicle's cameras. And my friends, these technologies, let's say, without much fanfare, are shaping the future of humanity when they are applied to other technologies that are used in our daily lives. Now we will see another one of these that seems simple at first glance, okay? But pay attention and you'll understand its real potential. 3 students from the University of British Columbia managed to develop an artificial intelligence capable of mastering air hockey by training exclusively in a virtual simulation. The achievement represents a very important step in one of the greatest ambitions of modern robotics: teaching complex machines without spending years on physical testing. Instead of teaching the machines in the real world, they made them make all kinds of mistakes inside a computer's simulation. The idea was not to create a perfect simulation. In fact, it was the opposite, to intentionally introduce flaws. The artificial intelligence trained on crooked virtual tables, with different frictions, camera delays, and even small variations in the motor's responses. By facing millions of unpredictable scenarios, the AI stopped looking for an exact formula and started acting much more like a human player. And the impact of this achievement goes far beyond games, demonstrating that an AI can learn entirely in the virtual world and then work immediately in the real world, has paved the way to accelerate the development of autonomous cars, industrial robots, and even rescue drones. And something similar, but inspired by bees, was used to teach this drone here. Take a look. Crossing hundreds of meters autonomously, finding its way back home, and doing all of this using less memory than a single photo stored on your phone? It sounds impossible, doesn't it? But that's exactly what European researchers managed to demonstrate when they developed BNAV. This is the new navigation system made for drones, inspired by one of the most efficient navigators in nature, the bee. Today, autonomous drones still rely on 3-dimensional maps that are complex and also require enormous computing power to locate themselves. The problem is that all this intelligence consumes energy, increases the weight of the equipment, and drastically reduces flight endurance. To overcome this limitation, researchers from Delft University of Technology, Wageningen University, and Oudenburg University decided to copy a strategy used in nature. Bees are able to fly long distances and return to the hive without GPS, without digital maps, and using only a tiny brain. BNAV replicates exactly this kind of principle. The system combines 2 main mechanisms. The first is visual odometry, where the drone calculates distance and direction by observing only the visual flow of the environment around it. The second is visual memory. Before leaving, the drone performs small flights around its base and, by doing so, records panoramic images that serve as reference points for its return. The results greatly impressed the researchers. Using a neural network of only 42 kilobytes, BNAV completed outdoor flights of up to 600 meters away. However, in outdoor tests under strong winds, the rate dropped to about 70%, thus revealing the main current challenge of this project. And speaking of challenges, my friends, pay attention to this one that was overcome by an advanced humanoid robot. This one is really interesting. Running over uneven terrain, jumping over obstacles, and entering dangerous areas filled with smoke, heat, and high electrical voltage. This kind of work, which is extreme, used to be reserved for highly trained human teams. But the Chinese company Jeep Robotics introduced the DR-02, a high-mobility robot designed to operate in hostile industrial environments, also, of course, in combat scenarios, including fires. The demonstrations released by the company show the robot capable of running over uneven grass, climbing stone or concrete steps, and performing inspections in high-voltage electrical installations. Deep Robotics' goal is to take humanoid robots to places where the risk for humans is simply too high. Unlike prototypes created for controlled environments, The DR-02 was designed to face the unpredictable conditions of the real world. Standing at 1.75 meters tall, it has an IP66 certification which offers protection against dust and powerful water jets. The machine was also developed to operate in extreme temperatures, ranging from -20 degrees to +55 degrees. Its mechatronic actuators have received important updates, thus increasing the load capacity and improving the movement speed. These are fundamental features for transporting emergency equipment in critical situations. The fact is, the DR-02 shows that humanoid robots are already beginning to gain the physical strength needed to operate in scenarios where human presence is extremely risky. But the next frontier will be much more complex, my friends. Turning these machines with built-in artificial intelligence capable of running and jumping into synthetic beings that are safe to be around us humans, without harming us, either intentionally or even by accident. If you enjoyed this episode, please like and make sure you're subscribed. Sometimes the platform unsubscribes you, so check, it's free. Thank you for sticking with me until now, and I'll see you in the next one. Just click on one of the 2 suggestions on your screen, okay? I'll see you there. Thanks for watching. Bye-bye. See you soon.